Okay, we are going to do 5 questions today. One from 1, and we already said we're going to do number 73.
3.
With gusto. All right. So we have the quadratic. The first thing I would do, if it's not already, and this one is, I'm just going to rewrite it so I can read a little bit better. I would make sure you put it in standard form. So if you look at some of the other ones, you know, the B might have come first, whatever. Put it in standard form so you don't get things mixed up. All right, they want you to be able to find the vertex. How do I find the vertex? Very good. The H part of the vertex is negative B over 2A. So negative 12 over 2 times negative 4. I'm getting 1.5. You asked me if you get any kind of calculator tomorrow. Yes.
So you don't want to fraction 1
It doesn't matter. If you have 3 over 2, negative, if you have positive 3 over 2, that's fine. Okay? When I plug in, it's easier for me to plug in a decimal. And since it's a nice, pretty terminating decimal, I would use the decimal just to make it easier. So your K, you are plugging that specific X in to find our corresponding Y value. Okay, so your vertex is 1.5 comma 16. What is the axis of symmetry? What is it? What is it?
1.5.
X equals 1.5. So remember, if you don't put the X, I'm going to take a point off. So make sure you're writing X equals. It's a line. Let's see. What is the Y-intercept? 7. Right, it's the constant. X-intercept. We're going to set the function equal to 0 and solve it. Okay, we are going to go ahead and do the quadratic formula. We could have factored this. But that negative A value is kind of hard to see. So the square root of 256 is 16. Okay, so we have 1/2. And 3.5 or 7 over 2. So that's as much as we can do to figure out before we graph it. So since these guys are real, a lot of you guys had questions on your take-home quiz. If you have imaginary X-intercepts, are they X-intercepts? No. So if you have imaginary numbers there, there are just no X-intercepts. You just would say there are none. Let's make it smaller so we can graph a little bit better. All right. So remember, it is a quadratic. Our vertex is 1.516, so let's pretend that we can put it on the graph. Our X-intercepts are negative 1.5 and 3.5. Negative 1/2. So we can just graph it from there. Our y-intercept is 7. So we'll have a better graph hopefully tomorrow. Okay, so you can find all that stuff. That's the important part. The graph's not important. That's
We have like a graph on the thing where we have to like draw the axes.
oh no, I mean it'll be given to you.
Okay.
Like it'll be like you had on your table. Okay? Be good. Moving. Oh, no, but is there a max?
Yes. Yeah.
What is the max? 16, right? But you should be able to tell if it's opening up, down. Sorry, I didn't go over that. You guys are good with that, though?
Yeah.
It opens down, obviously. All right. Given a polynomial, you'll be able to find the end behavior, zeros, multiplicities, y-intercept, maximum number of turning points, and be able to sketch it. Which one do you want to go for?
60. Oh wait. I was 60.
60? You go with 60? Everyone's voting? Okay. Okay, this is already factored for you, which is nice. So we can find our zeros right away. What's the first guy? If I set the first factor to 0, I get x equals 0, multiplicity of 2. If I set the second factor equal to 0, does it give me real zeros? No, because when I do x squared plus 1, it's minus 1. And the third factor gives me x equals 2, multiplicity of 1, if you will. All right. So we've got our zeros. Now be careful. That middle factor, I'm going to go ahead and write this. That middle factor, if I set this equal to 0, I get x equals plus or minus I. All right? That's why we're not going to include it in our x equals. But what is the degree of this function? It's a degree 5, right? It only has 3 real zeros, but it's still a degree 5. So if I were to FOIL all that together, you need degree 5. So we don't need these, just understand that they're there. So I have a degree 5. Is it a positive or a negative leading coefficient?
Positive.
All right, so we are basically looking at end behavior that looks like a line, a positive line, yes? That's not what the graph looks like, it's what the end behavior matches. Okay, so if I'm going to write the end behavior, the limit as x approaches negative infinity equals what? As x goes to the left, what's the y doing?
Positive.
As x goes left, it's going
Oh, negative.
negative infinity. As the x goes to the right, to positive infinity, what's the graph going to? Positive infinity. Make sure you know how to write end behavior.
So you know the line that looks like that because
It's an odd function, and it's positive. So the positive line is the smallest odd degree guy you can think of. Okay? It's the easiest one to sketch. All right, what else we need to find? Y-intercept. How do I find the y-intercept when it's all factored like this? Can I just plug in y for the, or 0 and for the x? Sure. So if I plug in a 0, the first one's 0 squared, so that tells me something here. Well, there is one. It's called 0, okay? All right, let's sketch this guy. All right, we have a 0 at 0 and a 0 at 2. Tell me, how is the graph or the function crossing at 2? Is it crossing? Rephrase it. Is it bumping, crossing, or jogging? At 0.
Or
Bumping. I think I did it too. Okay, so it's bumping at 0, and what's it doing at 2? Just crossing, right? Simple cross. So our end behavior tells me I'm starting low. So I'm just going to put my pencil down here in the third quadrant. I'm going to go up. I'm going to bounce off that 0. I'm going to turn around, and I'm going to continue crossing at 2. Does it matter how low that minimum little valley goes? No, I don't care about that. I care about how it's crossing or touching the x-axis. So we need to see a bump here and a cross there.
Do you know that because of the exponents?
Multiplicity, yep.
If you're trying to figure out like the what is it called?
End behavior?
Yeah, end behavior. Like, what would it look like if it was like positive, negative, or if it was even negative?
If it's an even negative, it looks like an even or an upside down parabola. Right? Think of an x squared that's negative. The end behavior would both be negative infinities.
Okay.
If it's an even positive, they would both be going up. Okay? So you really only have to think of lines and parabolas when you're talking about end behavior. We good? This test is going to be so easy. We ready? Piece of tape. Okay, rational functions. Finding x and y intercepts, any vertical or horizontal asymptotes, and being able to sketch it. So which one looks good? $70? I don't care. Does that look good to you? Okay. Have one there. Actually, an interesting one to do. All right. What should you always do with rational functions? First thing, back as much as you can. Back as much as you can.
X plus 32 over x times x squared plus b.
There you go. That's as much as you can factor it. So, second thing I look for is any holes in the graph. Anything that's going to cause a hole. You see a factor that cancels?
X
The x's cancel, right?
whole.
So there's a hole. At x equals, you set that equal, 0. So help me out here. Where would the y part of the hole be? Plug the x into what's left. 0. So up top, if this x squared was 0 and this bottom x squared was 0, what would you have left? 4, right? 32 over 8. So I have a hole in the graph at 0, 4. Great. Okay. Do we have a vertical asymptote? So we find vertical asymptotes by setting the denominator equal to 0. And when I say that, I mean after you've reduced any holes. When I go to solve this, I do not get any real answers. So So there are no vertical asymptotes. Okay? Like I said, interesting one you guys picked, which is good. All right, how about horizontal asymptotes? Horizontal asymptotes, you are looking at the degrees from the top and the bottom. So if the degrees are the same like they are, you're looking at the leading coefficients on top and the leading coefficient on the bottom. So it's going to be y equals 1 over 1, which is 1. Right? So the horizontal asymptote, you're looking at the highest exponent top and bottom. If they are the same like they are, the horizontal asymptote is the numbers in front. If they're not the same, if the top one is smaller than the bottom one, a horizontal asymptote is always y equals 0. If the top one's bigger than the bottom one, it's an oblique asymptote. You would just say there are no horizontal asymptotes. Okay? Okay, X-intercepts. X-intercepts occur when the y is 0 or when the function is 0. When is a fraction equal to 0? When the top equal to 0. So if I set the top equal to 0, I run into the same problem. I have negatives here, so they're not real. So there are no x-intercepts. Interesting. Notice that we have a hole when x equals 0, so couldn't there be a y-intercept? No. The y-intercept is a hole. This is going to be fun to graph because it looks like we have a lot of non-information. But it's good. It's all good. It's all good because we're going to graph it just with our brains and how good we are. All right. Let's think about what we have here. We have a y horizontal asymptote. Y equals 1. Good. We have a hole in the graph at 0, 4. That's it. So let's think about it. The graph has got to come in from the left side here along this asymptote. Is he going to be above or below the asymptote? It's got to be above because it's got to go in. The hole is the place where it jumps over. So it's got to go through that. All right. Does anybody notice that the function is even? Isn't the function even? If I put a negative x in there, I'm going to get the same function back. So we have a reflected graph here. So I know it's going to come along this asymptote. It's got to curve up, and it's got to look the same on the other side. That's the only way it can go. There's nothing else that graph could possibly do, right? There's no x-intercepts. It's not going to be below the horizontal asymptote at all. That's why knowing those even and odds kind of help you get a clue too. Now, being that I am mean, but I'm not that mean, do you think something like that's going to be on your test? Probably not. It would more likely be one where, like on your, where you have, you know, some asymptotes that run above or below, that type of thing. Right? Would you like to try a different one?
Yeah.
I like that one though. That'll make you think a little bit, right? All right, let me pick one. You guys are just crazy. Let's pick just a generic one. It looks like this one. 66 looks good. Don't yawn yet. I have to be here till 7:30. We have conferences. All right, so this one has a little bit more meat to it. That you could possibly chew on. The other one was a little scary. All right, so I'm going to give you 2 minutes here. Figure out as much as you can. Okay, you check up here. You see that there's no hole, right? Because no factors cancel. So you have 2 vertical asymptotes because you have 2 factors in the denominator. You have 1 horizontal. How do I know the horizontal asymptote is 0? What's the degree at top? 1, and there's 2 x's on the bottom, right? So that degree is 2. So small over big is always 0. X-intercept when the top equals 0. Y-intercept is when x equals 0. We're all good. We can all find that stuff, right? There's no oblique asymptote. Oblique is when there's no horizontal. All right, so here are our asymptotes drawn in. My x-intercept is at 1. My y-intercept is at 1/2. So you've got to figure out, am I coming in above the horizontal asymptote and going up, or am I going below on the left side? So what number am I going to put in? 2. On the left side of this guy. -2? Okay. So if I put in -2, up top I have, we only have to tell whether it's positive or negative, understand. So on the top I'm going to be -3. If it's -2 on the bottom, it's -1 times -4, which is 4. It's negative, right? So we're going to come along and the branches in that quadrant. Okay. Can you kind of already see what's going on the other side?
Is it -3?
Okay, if I put -2 on the bottom, I get -2 plus 1 is -1, and -2 minus 2 is -4, right? Remember, you're multiplying. You're multiplying those guys. Okay? All right. Can you tell that it's coming down? The y-intercept is bigger than the x-intercept, so it's got to be coming like this. And I would say it's going to continue. If you're not for certain, go ahead and plug in 1.5. See what 1.5 gets you. Up top, it's going to give me a positive factor. On the bottom, it's going to give me a positive here and a negative here. So positive, positive, negative means a negative. So it's going to keep skating down there. So it's negative. Now, on the other side of 2, I'm going to put in 3. Up top, 3 minus 1 is 2, which is positive. 3 plus 1 is positive. 3 minus, it's all positive. So it's going to be up here. So you really don't need to find an actual point if you're at 0, because the number doesn't really matter. You're just looking whether it's positive or negative. You can find a point. I don't care. That's going to be 2/4, which is 1/2. Okay? Does that make sense? All right. Okay, number 4, find all zeros given the polynomial 1, 0. What one do you want to do? 25? Sounds great. Okay, I'm not going to rewrite the question. So they gave you the 0, x equals 3 minus I. What else do you know right now?
Conjugate.
The conjugate, x equals 3 plus I. Good. Then what do we have to do? Write them into factors, right? I think that's kind of what you would say. Then what do you have to do? Boil them together, multiply them all together. So you're going to get x squared minus 3x minus xi minus 3x plus 9 plus 3i plus xi minus 3i minus I squared. So after you multiply those two together, you get that quadratic x squared minus 6x plus 10. What do I do with that? Divide it, right, into the big guy. So we're going to take this guy, and we're going to divide him. This long guy. Make sure you're looking for any zeros that might occur. Any missing exponents. There aren't any, but you never know. So you're going to go along here and do your long division. What should the remainder be? Should be 0, right? So you're going to double check that and make sure that happens. Not a 0. That's great. Now what do you do? You got a cubic up there. What do you got to do with that? You've got to try to factor it. It's a cubic, so it's got to be something to be able to factor. I can factor out the x. Okay? And then look to the quadratic. Can you factor this quadratic that's left? If you can't, then do the quadratic formula. All right? Because we're looking for all the zeros. They may all be imaginary. Is that possible with the 5th degree, though? No, one of them's got to be real. All right, so when we set these equal to 0, I get the zeros 0, -2, 1, and then do not forget your 3 plus or minus I. You should have 5 answers because we have a 5th degree. Make sense? Okay. Last one is the easiest question for tomorrow. I feel almost bad for this part. I mean, this is going to take you a little bit of time, but some of these are just too easy for you, I think. I'm going to leave them on there. Determine if the given value is a factor. Which one do you want to do? 41. Beautiful. All right, I'm just going to use synthetic division because I don't even want to pull out my big calculator. It's just easier without a calculator. So again, I'm looking for zeros when I'm writing these coefficients down. I don't have any zeros. I drop my first guy and I multiply. And I add and I multiply. And I add and I multiply. And I add and I multiply and I add and I multiply and I add and I multiply and I add. Yes, it is a factor because
Remainder is 0.
the remainder is 0 when you divide. Or the other way you can do it is I could plug in a -2. Which would be easier with all these parentheses? Synthetic division would be so much easier. Especially if I said, you know what, we don't need those calculators. Right? All right. No, because the remainder is 0. Make sure you put that. No, because the remainder is 0 when I did synthetic division. All right. We are done.